All right, friends and neighbors, welcome back to another BGP networking video. So previously we talked about where BGP came from and where autonomous systems came from, and that was our external routing protocol way back in the day. And now here we are at BGP, and specifically BGP version 4. So in this video, what we're going to do is go over some of the basic things that we need to use to build a BGP topology and then build a little tiny BGP topology, but it'll be enough to get us started and understand sort of the building blocks. So here we go, a little explanation and a BGP build. So what is BGP? Well, just as a reminder, right, BGP is a protocol that gets us connected to other autonomous systems. So we say it's an inter-autonomous system routing protocol. So if we think of a network as a graph, and we could be talking about a layer 2 graph, a layer 3 graph where the routers are the vertices and the networks are the edges, or we could be talking about a much larger scope where the graph vertices are ASs or autonomous systems, and then we're providing connectivity to the networks behind those or that are part of those autonomous systems. So the primary function of a BGP speaking system is to exchange network reachability information with other BGP systems. Okay, pretty straightforward. That's actually what we do with most routing protocols. Most routing protocols, so if you have an OSPF router, it's going to exchange routing information with another OSPF speaker. So from Cisco, BGP is mainly used to connect local networks to an external network to gain access to the internet or to connect to other organizations. Oh, so really, this is about a much larger scope, but when we get right down to it, we're trying to connect our internal networks to the rest of the world. Okay. Now, we do need a couple of things to get started. One of those is a BGP-ID. Another one is our peers, who are we going to talk to, and then we need an autonomous system number. So we'll break each one of those down a little bit. So the BGP ID and peers. By default, the BGP system, or at least on Cisco's, uses the loopback interface as an ID, and we'll see that later on. If you don't have a loopback configured, then it grabs the highest configured IP address. Now, this is similar to what OSPF does. It grabs an IP address that's one of your interfaces. Now, the bummer about that is that you never really know who you're talking to unless you have your topology memorized. So by using a particular ID or specifying the ID, and a lot of times making sure that ID is the loopback, we know exactly who we're talking to. Now, BGP peers are other BGP speakers that we're willing to communicate with. Now, unlike many routing protocols, BGP peers or BGP neighbors are not automatically discovered. You have to tell a BGP speaker who its neighbor is. In other words, who you're willing to exchange information with. And so there are two kinds of peers. We have internal peers, and those are peers that are the same autonomous system that you are. And then we have external peers, those that are part of a different AS. The topology that we're going to build today is external peers. Now, autonomous system numbers. Okay, well, we know that IANA is the Internet Assigned Number Authority. And you can go out there and take a look at all the IPv4 and IPv4 addresses, but they're also the authority for autonomous system numbers. So autonomous system numbers get registered. And then IANA allocates those autonomous system numbers to the various regional internet registries. And so you can go out and look at it. There's the link right there, but you can just go to iana.org. Lots of fascinating reading out there. Now, there are two flavors of autonomous system. Or I should say there are two flavors of autonomous system numbers. Those that are sort of pre-2009 and those that are post-2009. So previously, there were 2 bytes allocated to autonomous system numbers. That meant that the autonomous system numbers could range between 0 and 65,535. And it is just like that. So they're not like IP addresses. They're just a number that was allocated with 2 bytes. Well, there was a lot of demand for autonomous system numbers. So in May of 2007, you can see down there that RFC 4893 said, maybe we ought to talk about a little bit larger address space for autonomous systems. And so that range was expanded to 32 bits. But again, it's not like an IPv4 address, it's just a number, but this gives us a range well out into the millions. Okay, now the successor to 4893, I've got it here, is 6793, but there you go, the original discussion. So this started the discussion in 2007, and then 2009 was sort of implemented. Now, what you find out is that iOS version numbers, different kinds of devices, don't always support 4-byte AS numbers. Sometimes they're just the 2-byte. That's actually what we're going to run into today. Now, an AS number can have two formats, or be written in two formats. One is the pretty straightforward number, right? AS plain. So that would be just writing down the number that you're using for the value. So 65,535. I'm going to use 10,000 and 20,000 today. Now the AS dot notation is sort of a conversion to the dotted quad notation that we're used to. So if I was going to write down 65,537, I would write down 1.1. So the 1 indicating that it's 65,536, and then of course the 1 would be the remaining number. Okay, so that is our AS number formats. I got a little robot on this slide because I was just wondering if autonomous robots, autonomous vehicles ought to have autonomous numbers. Okay. Now, types of ASs. So from the American Registry for Internet Numbers, we have these definitions of autonomous systems. So you can have, I mean, if you think about it, we're going to build two stub ASs today. And so the stub ASs connects to another AS, and there's no really complex connectivity. We're also not using this AS to get to other ASs. We'll do another build later on. So multi-homing, meaning that we might have knowledge of more than one AS. So as we see here, a multi-homed AS connects to two or more ASs. Okay, and we would do that for redundancy. A stub AS is very straightforward. It is just connected to another AS to get out to the rest of the world. And then a transit AS connects multiple ASs to each other. And this is where we start to introduce maybe the conversation about iBGP and eBGP, where we would have internal BGP speakers and then external BGP speakers. Now, what are we going to see today? When we start our build, first of all, we have to remember, or we should remember, that this is a TCP connection. So exactly like any other TCP connection you're used to seeing, so the routers are going to establish that layer 4 connectivity. And we're going to do it on port 179. We also want to set up our loopbacks so that BGP automatically picks up its router ID or its BGP-ID. We will then specify the AS number. So when we set up OSPF, right, we used a process ID. In place of that process ID, we're going to use an AS number. And I'll try to go slow as I do the config so that we can explain each and every one of the steps. And then we're going to specify our neighbor, and then we're going to indicate what networks we want to advertise. So our topology will be very small. It'll be really straightforward to see what's happening. So our order of operations is that we're going to see TCP, we'll see a BGP open, and then we'll see BGP updates, and then we'll drop into TCP keep alives. Now, just quickly, this is actually what the conversation is going to look like up here. We'll see the TCP handshake and then a couple of BGP messages in that lovely purple there. So BGP open is very straightforward. It is going to be, I've established TCP, and now I'm going to issue an open connection where we want to start swapping BGP information. The header is very straightforward. Now, there's a base header for OSPF, maybe we'll talk about that, or for BGP, maybe we'll talk about that later on. But essentially what we've got here is my autonomous system. And remember that part of the configuration is going to be, I'm going to tell my BGP speaker who its neighbor is and what the autonomous system ID is going to be. and then the the BGP identifier for this particular router, and we'll see that it'll use the loopback. And there we go. Now, once we do that, we're going to do some updates. And once we do the updates, right, this will be routing information between the BGP peers, right? These are the networks that I wanted to advertise. And then what we should see is that we get a BGP route, just like this here. And then we start to build our graph of our AS numbers. That'll about do it. So let's go ahead and build. So I'm going to grab a couple of routers here, and I'll do this from scratch for you. And, we'll do the whole thing. So what I'm going to do is establish, my my networks first, and then we'll do the BGP configuration. Whoops, that's not what I want to do. Come here, you. And we'll label this to make sure that we understand what's going on. All right, I think this is pretty straightforward. So what I'm going to do is we're going to make this the 1.0 network, and we'll make it a /8. Make sure I got my octets right. And we'll make this the 2 network, also /8. And we'll make this the 3 network, just to make life really easy. Now I am going to do a loopback on each one of these, and we'll do 10.0.0.1 here, and 10, whoops, we'll do a loopback, 10.0.0, whoops, 0.0.2. Oh, let's do this too. We'll do my AS number is going to be 20,000 here, and my AS number here, ASN will be 10,000 here. And I think that does it. Yeah. Okay, so here we go. Well, I'll add one other detail. This will be 2.2.2.253, and we'll 2.2.2.254. We'll do like that. All right. So without further ado, here's our configuration. So we're going to say no, and we will say config t int f0/0 IP address 1.1.1.253 0.0.0, and we'll do a no shut. And we see this come up so that I know I was talking to the right interface there. And then we'll say int f0/1 IP address 2.2.2.253, like that. We'll also no shut this. This one's not going to come up because the other router is down. While we're here, we'll also do our loopback. All right. Well, don't want to autocomplete. That's okay. Okay. Loopback 0, and I'm going to say IP address 10.0.0.1. Maybe we'll use /24 for this. Okay. And over here now, we'll get this one ready to go. T int f0/0. This will be IP address 2.2.2.254, like that. And we'll say no shut. And we see this little arrow just went green, right? Int f0/1. IP address 3.3.3.250. Let's see, on those sides I do 254. Like that. No shut. And then we'll say interface loopback 0 over here. We'll say IP address 10.0.0.2. There we go. Now, if I take a look at my routing table, that's not going to work. I can see that I have, in this case, this is my router 3 here. I've got the 2-net, I have the 3-net, and then I have my loopback right there. Okay, so that is my routing table. My routing table for this router will be very similar, except it'll be the 1 and the 2-net and the loopback. There we go. All right. Well, now it's time to configure our BGP stuff. So let's get started here. And the first thing that we need to do is say, well, I want to do some BGP stuff. So now don't let me forget that I want to make sure we do the simulation before I bring up the second router. What I'm going to do is say router BGP. Now this is very similar. Router OSPF, router RIP. Okay. Well, what do we need here? We need an autonomous system router, and I think, or an autonomous system number. And what I think I said it was going to do is 10,000 on this one. And we don't need to say anything else. So there we go. Now, what do we have as options here? Well, I could do BGP stuff right now, but really what I need is to specify a BGP neighbor, and I also need to specify the network that I want to advertise. So in this case, we're going to do a neighbor or peer. Well, what does it want from me? It wants the address. Okay. 2.2.2.254 is the neighbor. And then what else? Well, this is going to be a remote AS because it's not part of my AS. So we'll do a remote. And what's the autonomous system that I want to use over there? Well, I think I said I want to use 20,000 over there. So we'll do this. Okay. So I like that. Now, what network am I going to advertise? Well, the only network that that neighbor doesn't know about is the 1-net. So I'm going to say network. Well, 1.1. Whoa, let's not get crazy here. We don't want to advertise our loopbacks yet anyway. Now, it gets a little tricky because it wants the keyword mask. And the nice thing about BGP, at least this version of the iOS, is that it says, I don't need you to use wildcards. Go ahead and use regular network masks. Okay, do we need anything else? Nope, I like that. That looks pretty good. And that's it. I'm going to, we'll do a show run here real quick on my configuration. There's my IP addresses, okay? And there's my BGP configuration. That's pretty much it. Now, if I watch, maybe I'll move this over a little bit. If I watch what my simulation is doing now, and I say, what's going on here? Look at this. We're trying to establish a TCP connection between these two routers. But the router is saying, look, I am not ready to TCP with you yet, right? But what we can see is that, I guess we do the flags, right? So the flags at this point would indicate that we're not actually ready to swap BGP information, but we can see that we've got port 179 being used for this connection. Now, if they were ready to BGP speak, what we would see is that we would see BGP going back and forth. Okay, let's go to real time. Actually, we will leave this as the simulation so I don't forget. Okay. So we know that the router on the left, right, router number 2, is trying to establish a connection. Well, let's give them another BGP speaker to talk to. So we're going to do config T, and I'm going to say router BGP. Well, what does it want again? My autonomous system. This one is going to be 20,000. And what do we want to do? Well, it's manual. Even though I turned on BGP here, or I started my configuration, they should not be able to find each other until I tell them what their neighbors are going to be. So I'm going to say your neighbor, whoops, like your neighbor is 2.2.2.253. And what are we going to talk about this neighbor? Well, it's a remote AS. And what is the AS number over there? 10,000. Still trying to TCP over there, but I'm not advertising any networks yet. So let's do, and remember that the simulation is kind of weird. It's very, very slow unless you fast forward it or hit the play button. What network are we going to advertise here? Well, this one is going to be the 3net. It's all the way on the right side of our topology. So 3.0.0.0, our mask, 255.0.0.0. And what else do we need? Well, that looks like it. So the two sides will be advertising the 1 and the 3net to each other. And that's it. So we will we'll let the simulation run. Well, we'll click through it. So we jumped to TCP, right? They're getting there we go. There's a BGP message. What is this BGP message? So a couple things. We can see that this is 179, and this one happens to be, now the direction is going to be important to us because we're going to pick up an ID here in a second. But this one is coming from 254, so we'll have to remember that. And we've got a BGP open here. So here's the base. There's our AS number. There's an ID. How do we get this ID? So remember that the ID is based on one of your interface IP addresses. And by default, if you have a loopback configured, it should be based on the loopback address. Well, let's see how in the world we got this particular number. Now, if I do the binary for this particular number, what we're going to do is we're going to look at, I'm going to put it in there in binary, and then we'll see what happens in the base 10 number. So the router on the right that has the 2.2.2.254 as the source IP address has a router ID, theoretically, of 10.0.0.2 from the top, 1001010. Now so this is the loopback that we're trying to convert to binary. So we need that's the first octet. We need the second octet, 1, 2, 3, 4, 5, 6, 7, 8. So this is 10.0, 1, 2, 3, 4, 5, 6, 7, 8. So this is 10.0.0. And then we need 1, 2, 3, 4, 1, 2, 1, 0. There we go. So now if we take a look, so this is the binary representation of the IP address, the 32-bit IP address with the leading zeros suppressed. So if we take a look at this number right here, 167.772.162, and we compare that, see if I can put it right next to it here. There we go. So where I am looking is this IP address conversion here and this one right here. And it turns out that they're the exact same thing. So what that tells us is that A, the IP address has been converted to a base 10 number, and B, that we are in fact using the loopback for an ID. Okay. Well, we close this. So that was the loopback, or the so that was the BGP open. Let's see what else we saw here. And there's our BGP update. We just had to wait a little bit for the simulation to catch up. And what are we talking about here? Well, this exchange is all about what networks we have. And so that's what we're going to tell each other. And remember that BGP is a path vector. Now we'll talk more about that, but these are the attributes of this particular connectivity. Now if we go back to real time here, what are we seeing? Did the routers in fact learn from each other? And we can see that the neighbor came up, very good. And if I do a show IP route, there's a BGP route right there. And we can see the admin distance for BGP. We'll find out that there's a different admin distance for iBGP and eBGP. But there we go. So there is our BGP learned route. And then we can do things like show IP BGP neighbors. And we can learn a little bit about what our neighbors are actually doing. All right, I think that does it for our basic BGP build. All right, high five if you got all the way through this. This was the basic BGP build and a little explanation about what we were going to see. So we got some AS numbers, we got some BGP IDs, and then we've got our peers with standard messaging. Don't forget your BGP flavors, right? It might be the autonomous system flavors or your internal or external BGP and all of the messages that are exchanged. Well, thanks for watching. Thanks for listening. Like and subscribe if I helped, and may those BGP packets always reach their destinations, no matter what kind of autonomous system you're going through.